Let's start this deep dive with a foundational and, frankly, a pretty terrifying challenge. What is reality?
Right.
We are clearly experiencing something right now. You, me, the listener, the chair we're sitting in. But maybe the truly critical question isn't what reality is, but is it real? Could everything we see, everything we experience, everything that exists in our entire universe be entirely artificial?
It sounds like the plot for a summer blockbuster, I know, but the moment you start looking at the profound philosophical, mathematical, and even, the quantum evidence that this is a highly advanced simulation,
Yeah,
the more those specific nuggets of knowledge start piling up into a mountain.
absolutely.
Today, we are deep diving into the sources supporting the idea that we are living in a computer-programmed reality. Our mission is to move far beyond science fiction and look at the serious arguments that suggest we are effectively running on code.
And finding the glitches that point to a system architecture.
Exactly.
And while the idea that reality might be artificial isn't new, I mean, ancient cultures across the globe have debated versions of this for millennia. The modern, highly specific, and sort of computationally driven version of simulation theory. It really starts with one major thinker,
It does.
which is where we have to begin our unpack.
That's right. We start with the Oxford philosopher Nick Bostrom. In 2003, he published an incredibly influential paper. It was titled, "Are You Living in a Computer Simulation?"
And this really set the stage for the whole modern debate.
It absolutely did. It established the precise intellectual framework that dominates the discussion today. Bostrom argues that assuming advanced, hyper-realistic simulation is even possible.
Which, given our current technological trajectory, seems like a very fair assumption.
A very fair assumption. He says if you accept that, then one of three things must be true. He calls this the simulation trilemma.
It's the ultimate cosmic multiple choice test, right? And the key is that these three options are meant to be logically exhaustive and mutually exclusive.
Exactly. Option one, we, meaning humanity or, any civilization like us, we destroy ourselves or we collapse technologically before we ever reach the capability to create these hyper-realistic, what he calls ancestral simulations.
We just don't make it that far.
We just don't make it.
That seems depressingly plausible, just given our history and current challenges.
It is, but let's look at the alternatives. Option two, we reach that capability. We can create these perfect simulations, but for whatever reason, and this is a critical point, we collectively choose not to use it.
Why would we do that?
Well, perhaps due to some universal moral restriction or maybe an overwhelming resource constraint that makes it impossible, or even just, cultural stagnation sets in.
But if computing power becomes essentially free, which is sort of the assumption Bostrom makes for a sufficiently advanced civilization, why would they choose not to simulate?
Right.
Wouldn't that be the default, almost irresistible scientific project?
Precisely. If the resources required for a simulation drop to near zero, the moral argument against option two becomes incredibly weak. Why suppress curiosity?
Yeah.
Why suppress historical research?
Or even just pure entertainment?
Exactly. This is why Bostrom assigns option two a pretty low probability, provided we survive long enough to get there.
Okay.
Which leads us to option three. We are definitely in a simulation.
And the unsettling realization is that Bostrom, using, rigorous probability arguments based on these premises, he concluded that each of these options is pretty much equally likely to be true. That 33.3% chance that everything we know and feel and touch is a construct, that is a deeply challenging idea. But what mathematical leverage gives option three such a high probability?
It's a concept he calls the ancestral simulation.
Okay.
Think about what an advanced civilization would do. We already use incredibly complex computer models to study population dynamics, predict climate change, run historical battle simulations.
Right, we're already doing it on a small scale.
We are. So once the technology permits, the most obvious and interesting simulation a civilization would create is a complete simulation of its own deep past, its own early existence. That is the ancestral simulation.
And the logic here dictates that a civilization capable of that kind of computational feat, they wouldn't stop at just one simulation of their past.
They wouldn't. They would create many, perhaps thousands or even millions of these simulations for research or just for historical archiving. Now, if those simulated civilizations themselves become technologically advanced enough,
Oh, I see where this is going.
they might also develop the capability to create their own ancestral simulation.
Ah, the Russian nesting dolls of reality.
Yeah.
Simulations within simulations within simulations, all the way down.
All the way down. Potentially infinitely, the number of simulated realities The
Wow.
Sims, it quickly, overwhelmingly swamps the one single base reality.
Just statistically.
Statistically, if there is only one base reality, but that base reality creates a million first-level simulations, and those simulations create a million second-level simulations, then the overwhelming probability is that
I'm one of the characters.
you're one of the characters in a simulated layer, not in the foundational base reality.
That mathematical logic alone is really what elevated this whole thing from like a fringe theory to a mainstream academic discussion.
It is, and it's why powerful figures in the tech world treat this so seriously.
Right. It's no longer a matter of can we, but when they do, what are the odds we are the first?
Exactly.
When Elon Musk, who has funded all these AI and aerospace projects, was asked about the probability that our reality is the original base reality,
Yeah.
he said the odds are 1 in billions.
1 in billions. He places the chance that low.
And Neil deGrasse Tyson, the world's most visible science communicator, he's maybe a little more cautious, but still incredibly unsettling.
He is. He puts the odds of us being in base reality versus a simulated reality at 50-50.
A pure coin flip.
A coin flip determines whether everything we experience is fundamentally artificial.
And since this discussion crosses so many boundaries, it's philosophy, it's metaphysics, theoretical physics, we can't just rely on probability, right?
Right.
We need to look for hard evidence. We need to find the glitches, the deliberate constraints, and the coded architecture written into the fabric of the universe itself. Okay, let's unpack this, starting right at the biggest question mark of all, the cosmic origin point,
We begin with the Big Bang.
the very beginning.
Before that singular moment, the contents of the entire observable universe were concentrated into a space smaller than an atom. It was a gravitational singularity.
And incredibly hot and dense.
We know it was hot, a quadrillion degrees, and unbelievably dense. But here is the crux of the scientific challenge. There was no space and no time as we understand them. Our current laws of physics, particularly general relativity, they just break down completely at that singularity.
Which raises the immediate and frustrating and totally unavoidable question that has plagued both physicists and philosophers for centuries. What existed before the Big Bang? And how do we get a universe governed by structured laws out of absolute structuralist chaos?
Right. If you ask a quantum cosmologist, they might discuss ideas involving, quantum foam or the slow decay of dark energy or these pre-existent meta laws that allowed the universe to spontaneously inflate from nothing.
These are valid, incredibly complex theories.
They are, but they all wrestle with the concept of infinity and the initial conditions. Where did the initial conditions come from?
And if you go the route of faith, a theologian might talk about God creating everything, but then the follow-up question is always there. Where was God? What was he operating in before he performed the act of creation? The answers from both science and faith, they often feel equally mind-bending and abstract when you trace that timeline back to absolute zero.
But the simulation argument, it provides an answer that structurally is incredibly simple, it's elegant. The universe wasn't governed by known physics, it was just sitting there dormant as lines of code in a computer. And then, at the moment of the Big Bang, someone somewhere decided to boot up a program. The sudden, violent start of existence becomes the moment the simulation loaded its initial variables.
And if the universe is a program, then everything we measure, every single force we observe, electromagnetism, gravity, the nuclear forces, all of it must be written into that underlying code.
The program establishes the fundamental constants.
Right.
You can think of these constants as the required parameters in the programs, like initialization file. You have the exact set value of the speed of light, which acts as the maximum data transfer rate.
The ultimate speed limit.
The ultimate speed limit. You have Planck's constants governing mass, speed, and time at the smallest possible scales. Avogadro's number is in there, along with the precise values for the charge of an electron and the mass ratio of the proton to the electron.
And the argument for a simulation is really strengthened by the fact that these constants aren't just rules, they're fine-tuned.
Yes.
If these values were changed even slightly, just a few decimal places, the universe as we know it could not exist.
Absolutely. This is a critical point, often used in design arguments, whether the designer is a deity or a programmer. For example, if the gravitational constant were just a little bit stronger, stars would burn out in a fraction of a second.
So planets would never have time to form.
Never. If the ratio between the strong nuclear force and electromagnetism were tweaked, the complex chemistry you need for carbon-based life would be impossible. The universe appears balanced on a razor's edge.
Which suggests carefully chosen parameters rather than just some random accident.
It does, and that level of programming even includes us. The simulation theory suggests that consciousness itself, our subjective experience, our ability to think and perceive and observe, is not some magical emergent property of biological wiring.
But what?
It's simply a highly sophisticated subroutine within the simulation program.
That's a major philosophical hurdle, though, isn't it?
Right.
If the creators are simulating us, are they simulating our experience of self?
Right.
Simulating human behavior, the inputs and outputs, cause and effect, that's one thing. But simulating subjectivity, what philosophers call qualia.
The redness of red, the taste of chocolate.
Exactly. That requires calculating every subjective feeling of every single simulated entity. That sounds immensely costly computationally.
It does. But perhaps the simulation doesn't need to render our inner lives continuously. It might only need to render the illusion of a rich inner life until we, the simulated characters, demand proof of it.
So the program only provides the perception of self when we focus on it.
Right, to save immense resources. It connects back to this theme of efficiency, which we will keep returning to. But first, let's address the massive, immediate scientific pushback this theory gets: computational feasibility.
How could any computer simulate something this vast? But before we dismiss the idea, we have to consider the trajectory of our own technology. Moore's law, which stated that computing power roughly doubles every 18 months, held true for about 50 years.
It did.
And even if it's slowing now due to physical limitations at the microchip level, the progress is just undeniable. And most experts predict AI will surpass human intelligence, the singularity, within the next 100 years.
The change we have already witnessed is truly staggering.
And here's where it gets really interesting, where the historical analogy just lands. Think about the technological leap in simulation capabilities within our own lifetimes. As recently as the 1970s, the world's most advanced video game was Pong.
2 rectangles and a dot?
2 white rectangles and a dot. 40 years later, modern gaming engines produce footage, like the demo reels from Unreal Engine 5, that is virtually indistinguishable from photoreal reality.
It's incredible.
We have gone from 2 simple rectangles to photorealism in 4 decades. If a civilization is 6,000 years or even 600,000 years more advanced than us,
Their computational capacity would be just incomprehensible to us.
it would. However, we still have to face the hard scientific numbers championed by physicists like Dr. Mikio Kaku, who argue that simulating a universe is scientifically impossible even for a super advanced civilization.
Right. And the numbers are huge.
What exactly is the scale of that challenge? We need those numbers to understand the magnitude of the problem.
Kaku points out that there are an estimated 10 to the 80 atoms in the observable universe.
Okay, that's an enormous number.
It's a 1 with 80 zeros. To calculate the position and momentum of each particle, its quantum state, at any given microsecond, you might need, say, 128 bits of data per particle. That means the data storage required just to map the universe is on the order of 10 to the 83 bits.
And the computing power to track what they're all doing.
We're talking about 2 times 10 to the 80 floating point operations per second.
I mean, numbers so colossal that they are beyond human comprehension. They really define the limits of what is physically possible, even in theory.
Indeed. To power this, Kaku argues, the simulators would need access to megastructures like multiple Dyson spheres, capturing 100% of a star's energy output, or somehow harnessing energy from black holes.
His conclusion is pretty deterministic then.
It is. The only computer capable of simulating a universe is the universe itself.
That argument is airtight. If, and this is a big if, you assume the simulation has to render everything everywhere all the time, down to the quantum level.
Right.
But that assumption fundamentally misunderstands how efficiency works in sophisticated computer environments.
This is the critical refutation, which leans into the expertise of computer scientists, not just physicists.
Yeah.
That level of constant rendering is not necessary. Think about playing a massive open-world 3D video game today.
Okay.
Does the game engine calculate every single blade of grass, every ant on the ground, and the detailed interior of every distant building simultaneously?
No, of course not.
Yeah.
The system conserves resources ruthlessly. It only calculates what the player can see, or what the player is actively interacting with at that specific moment.
Exactly. If you are standing far away from a city in a game, the engine renders that city as a low-resolution facade, a few pixels in basic geometry, just enough to make it look real.
It's not calculating the plumbing.
It doesn't bother calculating the plumbing or the furniture or the complex internal physics of those distant structures. It only increases the detail, the fidelity, the resolution when the player actually approaches and demands to interact with it.
And if we are living in a simulation,
It would make perfect sense that the creators use this exact same resource-saving technique. They only render the reality we are observing, and the rest is just computationally cheap background noise.
and that leads us directly into section 2, the architecture. Because if the goal is resource management, setting strict limits and rigid rules is absolutely essential for operational efficiency.
They absolutely are. And those limits are encoded into the laws of physics.
Right.
As Max Tegmark, a cosmologist at MIT, points out, the strict laws of physics we observe point strongly to the possibility of a simulation. If you were designing a sandbox environment with billions of entities, you would need constraints to prevent computational runaway.
And the most obvious constraint is the hard cap on the speed of light.
Yes. Tegmark suggests that putting a hard cap on the speed of light serves as the ultimate resource management boundary. It's an excellent way to keep your Sims from venturing out too far from home.
So it prevents the simulated characters, us, from consuming astronomical computational resources by trying to explore vast distances instantly.
That's the idea. If we could instantly teleport across the galaxy, the system would immediately crash because it couldn't render the 200 billion stars we suddenly demand to see.
It's the ultimate firewall, preventing us from breaking the simulation by demanding too much rendering too quickly.
Right.
But the most stunning piece of potential physical evidence that suggests a programmed architecture, it comes from deep inside the fundamental forces of the universe itself, from the theoretical physics of string theory.
I'm talking about the work of the theoretical physicist James Gates. And what's important to note here is that Gates didn't set out to prove simulation theory. In fact, he initially dismissed it.
He was a skeptic.
A total skeptic. His research was focused on quarks, leptons, and the complex equations used to describe supersymmetry and string theory. He was just looking for deep mathematical structures.
And what he found was completely unexpected. It's a hallmark of design systems.
He found error-correcting code buried deep inside those equations.
Wait, error-correcting code, you mean like the stuff that keeps your computer files from getting corrupted when you download them?
Exactly. Like hemming codes, or simple parity bits that engineers use to ensure that data transmission doesn't get corrupted by stray electrical interference.
So computer code, written into the very fabric of the cosmos.
That's what it looks like. Gates realized that if the physical laws were just random, why would they require the systematic, almost redundant structure of ECC? Why would the universe, at its smallest functional level, need to check its own math and prevent data corruption?
That finding suggests the universe isn't just described by math. It is information that requires maintenance.
It's a shocking parallel, especially when we remember that research from 2017 at the University of Washington, which proved that scientists could physically embed computer code, actual digital data, into strands of synthetic DNA.
The concept of nature being fundamentally structured and coded is moving far beyond mere theory.
It is. And the most pervasive, obvious evidence that the universe operates on a program rather than pure, self-organizing chaos is found in the omnipresence of mathematics.
So programmatic patterns.
Math dictates the structure of the natural world through certain inescapable patterns, most notably the Fibonacci sequence and its relation to the golden ratio.
Let's just quickly break down the math for the listener, just to be sure we grasp the regularity here. The Fibonacci sequence starts with 1 and 1, and then you just add the two previous numbers together to get the next.
Right, so 1 plus 1 is 2.
2 plus 1 is 3, 3 plus 2 is 5, then 8, 13, and so on. Theoretically forever.
And the golden ratio, often represented by the Greek letter phi, is derived from this. If you take any two consecutive sufficiently large Fibonacci numbers and divide the larger one by the smaller one, like 144 divided by 89, you always converge on the same irrational number phi, which is approximately 1.618.
And we see these numbers embedded everywhere in nature, dictating growth and form.
Everywhere.
The number of petals on a flower, almost without exception, is a Fibonacci number. Lilies have 3 petals.
Yeah.
Buttercups have 5. Daisies often have 34, 55, or 89 petals.
And it's not just the count, it's the spatial arrangement, the design itself. The spirals in a sunflower head, the arrangement of seeds, the scales on a pine cone all are arranged based on two intersecting spirals whose counts are consecutive Fibonacci numbers.
Which ensures maximal packing efficiency.
Exactly.
This holds true for larger structures, too. The formation of tree branches and roots often follows the sequence. Even the animal kingdom seems to adhere.
Right, the ratio of female to male honeybees in a healthy colony is precisely the golden ratio, 1.618.
And the human body conforms to this programmatic structure. We see the 1, 2, 3, 5 pattern everywhere. 1 nose, 2 eyes, 3 segments to our limbs, 5 fingers.
But if you look closer, the proportions are governed by phi. The length from your shoulder to your elbow, divided by the length from your elbow to your fingertips, that adheres to the golden ratio.
The famous Vitruvian Man drawing by Leonardo da Vinci perfectly illustrates this.
It does. Even the microscopic structure of life itself reflects this mathematical fingerprint. The DNA molecule, the fundamental building block of life, measures 34 angstroms long by 21 angstroms wide for each full cycle of its double helix spiral.
Those are consecutive Fibonacci numbers.
They are. These patterns are inescapable, pervasive, and highly non-random, dictating everything from the swirl of a seashell to the vast spiral arms of a galaxy.
And for simulation theorists, that level of deep mathematical integration and architectural consistency suggests a fundamental programmatic design, not just happenstance. Now, here's the crucial counter-argument we have to address, which skeptics often offer. They claim this is all just confirmation bias, that humans simply look for patterns in chaos because that's what we're programmed to do, so we find the golden ratio everywhere, even where it's not strictly necessary.
That is the ironic defense. And what's fascinating here is that in trying to dismiss the patterns as mere coincidence or human imposition, the skeptics actually concede the core argument of the simulation theory.
How so?
They reinforce the simulation argument by admitting the existence of a program that dictates human perception and behavior. They claim that our minds are pre-programmed to find structure, order, and rules, whether or not those structures are actually there.
So if our search for order is itself governed by a deeply deterministic program,
Then the entire human experience is subservient to the code, whether the code is external in the stars or internal in the brain.
so whether the rules are built into the universe, like Fibonacci spirals, or built into the observer, our programmed perception, the result is the same.
Exactly. The environment and the consciousness exploring it are fundamentally operating under a non-negotiable set of rules. We can't escape the program.
Let's pivot now from the deliberate architecture of the program to the anomalies, the moments when reality seems to slip up and reveal the code underneath.
The glitches.
The glitches. The legendary science fiction author Philip K. Dick was influential on this topic long before Bostrom formalized the theory. He believed that other realities are constantly being superimposed onto one another by so many film transparencies.
And he had a fascinating specific interpretation of déjà vu. He felt it wasn't simply a trick of memory or fatigue.
Yeah.
He theorized that déjà vu happens because something in our simulated universe, a specific data set, a foundational variable, had changed. Maybe a new timeline had branched off of the current one we inhabit, or the simulators had to patch a bug.
And the déjà vu we feel, that fleeting, unsettling sense of having seen or done something before.
Is the simulation engine correcting itself with the new information? But we, the player characters, we catch a glimpse of the old, discarded data before the new patch is fully integrated.
It's the only clue we have that the underlying variables are being tweaked by an external agent.
But the most profound, large-scale reality glitch we observe is what's called the Mandela Effect. This occurs when a large, often massive number of unrelated people share distinct, detailed memories of events that simply do not match the current verifiable reality.
Let's slow down on this, because this is where many people begin to feel truly unnerved. It's named after the most famous example, which is historically significant.
Yes. Millions of people vividly recall Nelson Mandela dying in prison in the 1980s.
I've heard this from so many people.
People remember detailed accounts of his widow on television, widespread global coverage, and a 2-hour funeral procession. They can cite specific details of the media coverage.
When did this ever happen? He was released from prison, became president of South Africa, and died peacefully in 2013.
Right. The collective certainty of this false historical narrative is what defines the effect.
And the effects extend into these minute details of pop culture, making them even more pervasive and easy to test.
Think about the Berenstain Bears.
Oh, this one gets me every time. It was Berenstein, with an E. I know it was.
A massive percentage of the population insists they remember the name being spelled the Berenstain Bears with an E. They argue it based on etymology. They argue it based on reading the books for decades.
Yet official records show it has always been Berenstain. Or what about the Monopoly Man? When you ask people, almost everyone describes him wearing a monocle over his eye.
But if you check the official logo or game pieces from any era, he has never worn one.
Even some of the most famous, quoted lines in cinematic history seem to be affected. The famous Darth Vader reveal. The line is, "Luke, I am your father."
But if you go back and watch The Empire Strikes Back, the actual line is, "No, I am your father." The false memory has completely replaced the actual dialogue for generations globally. It's not just a simple misquotation, it's a confident shared error.
We do have to acknowledge the strong counter-arguments from cognitive science here, though. Skeptics rightly point out that the human mind is highly unreliable. Very true. We suffer from confirmation bias, source monitoring errors, where we remember the information but forget where we learned it, and the simple fact of confabulation, where our brains just fill in memory gaps with plausible but incorrect data.
And social contagion plays a huge role. If enough people believe something, others may adopt the false memory. That is the responsible scientific view.
What?
But the simulation theorist posits, why is the system error so systematic? Why do the errors often converge on a highly specific, alternate, and shared detail? The sheer pervasiveness of these distinct incorrect memories suggests a systematic error, a widespread data corruption where a patch was applied, but not everyone's memory file was perfectly updated.
A systemic glitch in the memory matrix. Now, if the internal reality of human memory is glitching, what about the external reality? Let's transition from problems with subjective data to the biggest problem facing objective space exploration. Fermi's paradox. So what does this all mean when we look to the stars?
The universe is vast.
Yeah.
We estimate there are roughly 200 billion trillion stars.
Just an incomprehensible number.
It is. The Drake equation, which attempts to estimate the number of active, communicating extraterrestrial civilizations in the Milky Way galaxy, suggests there should be over 1 million advanced civilizations in our galaxy alone.
And mathematically, based on the age of the universe and the speed of colonization, the nearest one should be just a few hundred light years away, making communication or contact technically feasible given enough time.
It should be.
Yet despite decades of searching, we see absolutely nothing. This is the paradox, summed up perfectly by Enrico Fermi. Where is everybody?
And the simulation theory offers an extremely simple and computationally efficient answer to this cosmic silence. We are alone because the program only focuses on us. The rest of the universe and the millions of advanced life forms that should exist are simply not rendered.
It's the ultimate resource conservation strategy, coming back to that efficiency theme. If the universe is a video game, the creators are only investing processing power where the player is actively located.
Right. Why waste immense resources simulating 1 million advanced civilizations light years away, complete with their politics, their weather, their technology, if the player, humanity, will never interact with them?
If the speed of light cap holds true, and if we never venture out too far,
then distant galaxies are computationally cheap projections, just simple facades on the cosmic skybox. Only when we approach and demand detailed rendering would the system bother generating the necessary complexity. Until then, the universe is empty because the program deems it unnecessary to fill it.
This brings us to perhaps the most compelling piece of quasi-physical evidence cited by simulation theorists: the bizarre behavior of reality at the quantum level, specifically demonstrated through the Double-Slit Experiment. This experiment is a way to potentially test if our rendering engine is only calculating reality upon observation.
Let's meticulously review the basics because this is often misunderstood. If we fire particles, like tiny subatomic pellets, through a single slit at a screen, we expect to see them clump up directly behind the slit.
Makes sense. And if we fire waves, like water ripples, they spread out.
And if we fire those waves through a second slit, each slit creates its own wave, and when those waves intersect, they interfere with each other, creating a distinct light and dark interference pattern on the screen. Parallel stripes. This is the hallmark of wave behavior.
Okay.
Now here is the puzzle. If we fire electrons, which are matter, fundamental particles, through a single slit, they clump as expected. But if we fire those same electrons through two slits,
They don't clump like particles.
they create the wave interference pattern. They seem to be passing through both slits simultaneously, interfering with themselves.
This shouldn't be happening. For years, scientists assumed the electrons were somehow interacting or colliding with each other and behaving like a collective wave of particles.
So, in a modification of the experiment, scientists started firing only one electron at a time through the slits, ensuring there was absolutely no way they could interact or collide.
Okay, that isolates the variable.
It does. Yet, shot after shot, we still saw the wave interference pattern gradually build up on the screen. The single electron was behaving as a wave even when it was alone. It was impossibly going through both slits at once.
That is bizarre enough, matter acting like non-matter. But this is where it goes from weird to potentially revealing the system code.
Yes.
Scientists decided they needed to find out what was causing this wave behavior, so they added a detector, a measuring apparatus, to observe the electrons as they pass through the slits. They wanted to spy on them to see which slit they chose.
The moment the detector was activated and started observing the electrons, the wave interference pattern immediately vanished.
Just gone.
Gone. The particle clumping pattern returned. They suddenly behaved like classical matter, only going through one slit or the other.
It's as if the electrons realized they were being watched and snapped back into particle form, abandoning the computational efficiency of the wave state.
And the follow-up experiments confirmed this. If scientists turned off the detector but left it in place, as if they were pretending not to spy, the wave interference pattern returned.
The particles are aware of whether or not they are being observed.
It certainly appears that way, and for the simulation theorist, this behavior is the purest proof of the resource management engine at work. The quantum wave state is the unrendered, computationally cheap probability field.
It's just a superposition of possibilities?
Not fully calculated. The moment you look at it, the moment you need to interact with it, the program collapses the wave into a definitive particle, rendering the reality you demand to see.
It's just-in-time rendering applied to the fabric of reality itself. But physicist John Wheeler took this strange observation effect even further with the delayed choice experiment, challenging our understanding of time itself.
Wheeler wanted to test how much control our current observation had over the past path of a particle. In the delayed choice experiment, the critical decision, whether to observe the photon as a wave or as a particle, is made after the photon has passed through the slits but before it hits the screen and is recorded.
The shocking result was that the decision made in the present caused the waves to suddenly behave like particles. The electrons retroactively recorded themselves as having passed through the slits as particles.
They changed their historical state by effectively going back in time.
So the decision made in the present dictates the historical reality of the particle, even though the particle had already completed its journey through the slits tens of microseconds ago.
This retrocausality, where cause and effect seem reversed, is one of the most baffling results in quantum mechanics because it defies our linear understanding of time.
And when this experiment is scaled up, it becomes cosmically profound.
It does. Researchers performed the experiment using light from a galaxy 100 million light-years away. The light photons had already been traveling toward us for 100 million years.
So they're almost at the finish line.
Almost. They used a measuring apparatus to observe the photons as they arrived. Simply by choosing the method of observation, which, in the simulated framework, is the equivalent of the player asking the program to render the object.
The wave collapsed.
All the way back to its source, 100 million years ago, altering its state on the other side of the galaxy.
That means our observation today determined what the particle was 100 million years ago. This phenomenon where observation changes reality and fundamentally bends time backward.
It only makes sense if there is a non-physical program at work. Only a program can ignore the fundamental laws of physics and time itself, just like a video game engine that only renders the far-off galaxy if we are looking at it and demanding its existence.
Collapsing the probability field instantly.
Instant.
When you look at the totality of the evidence, from Bostrom's probabilistic argument to the mathematical blueprints, the systemic glitches, the bizarre quantum behavior simulation theory becomes a convenient case.
It is convenient. And it's convenient because, fundamentally, it is impossible to disprove using the rules of our own reality. It provides streamlined, singular answers for all the biggest cosmic mysteries.
Right. The simulation theory answers the Big Bang question. That was the program initialization, the system booting up.
It answers the absence of aliens and Fermi's paradox. They are simply not rendered because they are outside our computational focus, conserving resources.
And it even addresses high strangeness, such as reports of UFOs that appear to violate our constraints, accelerating instantaneously and changing direction without apparent inertia.
Why don't they adhere to our constraints? Because they are likely programs operated by the simulation creators, perhaps debugging tools or test assets, and they do not have to follow the rules of our localized reality.
They operate on the creator's level of authority.
Exactly.
Which leads us to the biggest implication of all, one that strikes at the core of human identity: the God question. If we assume the existence of a simulation creator, a hyper-advanced omniscient intelligence who exists outside of our understanding of space, time, and matter, doesn't that description sound exactly like the description of a classical, all-powerful God?
It creates a fascinating philosophical dichotomy. Many fervent believers in simulation theory are often fierce atheists. They dismiss the idea of a spiritual, supernatural God as superstition and faith-based nonsense.
Right.
Yet they fully embrace the idea of a creator intelligence running the universe from a base reality.
The difference is that they have simply replaced one kind of unprovable external creator with another. The programmer God replaces the deist God.
The creator is no longer divine, the creator is technological, but the function remains the same. An external entity designed the rules, initiated the system, and is aware of everything we do.
And conversely, you have plenty of devoutly religious people who might dismiss hard science like evolution or the Big Bang models, but who might find the idea of a pre-programmed, deterministic existence conceptually highly compatible with their faith.
They might simply argue that the base reality programmer is God and the simulation is their mechanism for creation.
This also brings up the crucial moral argument. Some people argue that if life is just a simulation without a traditional morality-defining God, then our actions don't matter.
Right, the nihilism argument.
If our reality is artificial, then our moral choices don't have ultimate cosmic consequences.
The counter-argument, and the one that holds the most weight philosophically, is that even if we don't live in what the creators call base reality, we still live in our reality. The subjective experience is real.
The pain we feel, the love we experience, the joy, and the immediate consequences of our actions on other simulated consciousnesses are all profoundly real here and now.
The simulated reality is the only reality we have access to. Therefore, the consequences of our actions, whether physical or emotional, are valid within this program.
The simulation's code dictates that kindness leads to connection and violence leads to suffering. We are bound by the laws of this system, regardless of its origin.
Exactly. This leads to the final synthesis. Both simulation theory and religious faith are non-provable, deeply deterministic belief systems attempting to explain existence, origin, and the presence of unavoidable rules.
And both require a fundamental faith in an unseen, omniscient, rule-making intelligence operating outside the constraints of our current understanding of time and space.
The difference between them is ultimately semantic, dictated by whether you use the language of science and computation or the language of theology and spirituality.
And that leads us to a final provocative thought for you to consider.
Whether you ultimately believe in a creator God who established the universe through divine will, or you believe in a hyper-advanced post-human civilization that simply pressed the run button on a supercomputer.
What is the fundamental difference between those two beliefs in terms of how you choose to live your life, how you treat other people, and how you understand your place in the universe? Does the label of the creator actually change the ethical demands of the creation?
We've taken a comprehensive journey through philosophy, Bostrom's trilemma, resource management, the mathematics of the cosmos, the glitches in our memory, and the time-bending strangeness of quantum mechanics.
The sources show that the evidence, whether it's mathematical, physical, or based on the anomalies in our perception, elevates the conversation about artificial reality from a fleeting thought experiment to a serious, scientifically engaged discussion.
Hopefully, this deep dive has given you plenty of new facts and insights to consider about the nature of the reality you are currently inhabiting.
Thanks for joining us for this deep dive.